Okay, so I'm going to walk you through these notes. This is the second part of electroconfiguration notes. So this will make more sense, obviously, if you've already completed the POGL. So make sure you've completed that first and watch that video, and then do this one. So just quickly, I'm going to go through just kind of these basic terminology sections, and then we'll kind of go into the rules of how to write our electron configuration. So the first part is talking about 4 letters that designate electron orbitals. So that is our S, P, D, and F. Okay, so these are like the rooms in the boarding house model. So like our sunny room S, our P room B. Okay, so we call these, we can call these subshells. Each orbital. So then when we start talking about like specific orbitals, that's like our bunk beds. So like this is an orbital, this is an orbital, and this is an orbital. So just like in our P room, we had 3 bunk beds. Well, we have 3 orbitals in our P shell. So each orbital can hold 2 electrons. Okay, so if I'm looking at if there's one s orbital in my s sublevel or subshell, that means only 2 electrons can be there, right? So there's 2 that can be here. I have 3 p orbitals in my p sublevel or subshell. Okay, sometimes it's called sublevel. Don't worry too much about distinguishing those terminologies. But if each of these can hold 2, so 2, 2, and 2, then that means that whole sublevel or room can hold 6. Okay, so then I have there's 5 d orbitals. So that's like 5 bunk beds. So that means that room can hold 10. And then for F, there's 7 orbitals or 7 bunk beds. So that sublevel can hold 14. Okay, so for this next part, if you kind of scroll down and look at this picture that I've included, this is how the periodic table is basically organized, just naturally the way that it's set up. We're going to talk more about kind of the setup of the periodic table tomorrow, or next week, but it is very helpful when we're doing our electron configuration, because the way that it's set up is actually the way that our energy levels are filled with electrons. So there's a pattern to how those electrons are filling our energy levels as we move across and down the periodic table. So we have our S subshell right here. Then we have our D across the middle. P is over here. Okay, and then our F, it actually fits in like right here. So I'm just going to put a little line and a little arrow. So let me erase this F part, that way it's not confusing. So this F section actually kind of fits in this little section here, but there's just not enough room on the periodic table to add that in there. If you did, then the table would be super long and it wouldn't look so nice and pretty on all the pages of paper and stuff and charts that you see. So that's why it's kind of pulled out to the bottom. We're not going to really use that very much, but you just need to know that it's there. Okay, so each row, notice how I have 1, 2, 3, 4, 5, 6, 7. I'm counting from the top down. Each row is an energy level. Okay, so if I have an element, if I'm looking at this element right here, okay, this element would have 5 energy levels, okay, because it is on row 5. So if I'm looking on your notes sheet, sorry, we'll have to scroll back up. It's saying, okay, well, if my first energy level only has the S sublevel, how many total electrons it can hold? Well, S only can hold 2, so that means this energy level can only hold 2. The second energy level has S and P. So S holds 2, P holds 6, So that means that energy level can hold 8 electrons. Which makes sense so far if we think about what we've learned about the Bohr model in the past, right? When you were ever filling in electrons, you always put 2 on the first circle, and then your next circle, you were told it could hold 8. So this is where those numbers are coming from, is based on how many s and p orbitals you have. So if I'm looking at the third energy level, and it can hold s, p, and d, that's 2 plus 6 plus 10. So that's 18 total electrons. Okay, for the fourth energy level, and anything past that, that's really 4th through 7th. Sorry, I didn't mean to write S. 2 plus P is 6, D is 10, F is 14, so that makes it 32 electrons, okay? So here, we're just restating the rules of how we're filling up these orbitals. So you should be able to fill this out just based on the POGL, but sometimes it's helpful just to have it kind of all in the same place without so many words. So it's saying, number 1 is saying electrons will fill the energy sublevels, filling up the lowest energy level first. So that's C, off bow, and I remember that because A is the first letter in the alphabet, and electrons are always going to fill up the first energy level first, or the lowest energy level first. So that's kind of how I remember that one. And then 2 electrons occupy the same orbital, but they must have opposite spins. That one is A, the Pauli exclusion principle. And I remember that because like spin has a P in it, okay, and so does Pauli. So spins and Pauli. So anytime you see something talking about opposite spins, that's our Pauli exclusion principle. And then that just leaves Hund's rule as the last one. That's talking about how electrons are only gonna pair up after each orbital has 1, just like you only pair up the bunk bed, people, after each bed has 1 person in it. You're not gonna put someone on top until there's at least 1 in each bed. Okay, so down here, this is just kind of a practice on can you write the manager's code. So remember, my first number, right, is my energy level, and then I have the letter for the orbital. So 1s, and then my exponent is just how many electrons. So there's 2 there, 1s2. The next is 2s, and there's 1 electron there, so that's 2s1. And it's asking me what the element name is. So how can I find my element name? Well, I know that my atomic number is equal to my electrons in a neutral atom. So all I have to do, if I have 1, 2, 3 electrons, I have to find the element with an atomic number of 3, and that is lithium. So if you want to pause here and practice these last 2 together before I write them answers out, that is fine. Then you can kind of check yourself. So the next one, I have 1s. There's 2 arrows, 2 electrons. I have 2s, 2 arrows, 2 electrons. And then I have 2p, and there's 2 arrows, so 2 electrons. So 2, 4, 6, atomic number 6 is carbon. Last one, 1s2, 2s2, 2p, 5. So 5, 6, 7, 8, 9. Atomic number of 9 is fluorine. Okay, so basically, in the next page, we're going to kind of work backwards from this way. So you've kind of seen how to draw what we call an orbital diagram. Okay, so we're going to practice drawing those by starting with the element, and I'm going to show you how we're going to do that. Okay, so there's 3 ways to show how electrons are organized in an atom. We have this orbital notation, which is what we just saw with the boxes and the arrows. We have our standard electron configuration, which is like the manager's code. Okay, and then we have what's called a noble gas configuration. This is like a shortcut, and it's super handy. Okay, so let's look at oxygen first. Okay, so I'm going to scroll down to my periodic table, and I suggest you pull out the periodic table from your the back of your lab manual. I believe it's like 143 or something like that, because you're going to need to reference a periodic table as you do this. So you're going to want both, like this picture and a periodic table. So oxygen is right here. Let me get a different color. Oxygen is right here. Okay, there's my oxygen, so I'm just kind of filling it in here. All right. So it asked me how many electrons oxygen has. Well, the atomic number is 8, so I know it has 8 electrons. Okay, so when we write an orbital notation, what we're going to do is we're going to write these boxes, okay, and we're going to follow the same like boarding rules as the house. So remember, the house only had a 1s on the first floor, so we only have 1s in our atom. Then they can move to the second floor, which was the 2s room. Okay, and then we have the 2p room. Remember, 2p has 3 bunk beds. So I don't write the box because it just gets to be too cumbersome. I always just write a line. So remember, the line is showing how many bunk beds you have or how many orbitals, and then the number and the code, the letter on the bottom is telling you the room. Okay, so how did I know that I needed a 1s, a 2s, and a 2p? So let's go back to look at this picture. Okay, so here's oxygen. If I look at my letter here, the thing with writing electron configurations is we're always going to start here at the beginning. Okay, so if you want to write a start. So if you look, I have 1s, I have 2s, and then over here I have 2p. So I know that this oxygen, all of its electrons are going to live within those orbitals. Okay, and then I know that each orbital can hold 2 electrons. And I can draw that with an arrow. And remember, Pauli's exclusion principle tells me that I have to have opposite spins. So I'm drawing one up and one down. That's showing that they're spinning different directions. And what that means is like, if I have an orbital that is like the s orbital is a circle, that means I have one electron that's spinning this direction, and then I have one electron that is spinning this direction. And so they're kind of bypassing each other, okay? And they're in constant motion. So then when I get to 2p, remember Hund's rule tells me that I have to put an electron in each bed or each orbital before I can double up. So I know I already have 4, so I need 4 more. So 1, 2, 3. So there's 3 of them. Notice I drew them all with the arrows pointing up because that is part of Hund's rule also. You have to have the arrows, or when they're singles, they're always have the same spin. And so you can see that up here too in these drawings, right? They always have the same spin. So I still need 1 more electron. So now I can come in, I'm just going to add it to the first one. That's usually what's done. And I remember have the down arrow because it's an opposite spin. Okay, so now I can write my standard electron configuration or the manager's code. So we're doing just what we did up here in the top. So I have 1s, 2, 2s, 2 because 2 electrons, and then 2p, 1, 2, 3, 4, 4. Okay, we're going to skip noble gas configuration right now because I want to get good at these 2, and then we're going to come back and fill those in. And like I said, it's a nice little shortcut, so it'll be fairly quick. Okay, let's do sodium next. So we're going to skip chlorine for now. Let's do sodium. Na has 11 electrons. Okay, so I know if I look down here, let me erase my oxygen. Okay, and here's my sodium. It's on row 3. So I know that it's going to have 3 energy levels. So I'm going to have a 1s, a 2s, a 2p, and a 3s. So 1s, 2s, 2p, oh, and a 3s. Okay, I think your page is a smidge bigger than mine on here. So now I'm just going to start adding my electrons. So I need to fill up my 1s, then I can fill up the 2s, then I can go to 2p. Notice how I put a single in each one, then I go back and fill in, right? And that gets me 10, 2, 4, 6, 8, 10, and I need one more to make 11. So I'm going to go add it to the 3s. So when I write the standard configuration, I have 1s, 2, 2s, 2, 2p, 6, 3s, and there's just one electron in that 3s. Okay. Let's look at aluminum, which is just a little bit further past sodium. And I'm going to show you a way that we can do this without drawing those arrows every single time. So you'll have to, you might have one or two questions about the arrows and how to lay those out, how to draw those on the test, but most of it will be just writing out the configuration. So let's look at aluminum. Okay, aluminum has 13 electrons, atomic number 13. I'm going to skip over drawing this orbital notation for now, and I'm just going to look at the standard. Okay, so how can I go straight to standard without drawing all of those arrows? So remember we said we always start right here. Okay, so this is labeled as 1s. Wonder if I can get this to see. Yep, oh good, I can see both. So I'm going to write a 1s. How many boxes are labeled as 1s? I have this one and this one, so that's 2. Okay, I'm at the end of the row here, so now I'm going to go back to the second row. The next thing I have is 2s, so I'm going to write 2s down. How many boxes are labeled 2s? I have 1, 2, 2s, 2. I'm just going to keep moving across my row, right? Now I'm at 2p, so I'm going to write 2p. How many boxes are labeled 2p? 1, 2, 3, 4, 5, 6, right? Which makes sense because we said that s orbitals can only hold 2 and p can hold 6. So once it gets to 6, it's full. You come back down to the next row, 3s. How many boxes are labeled 3s? 1, 2. Keep going across. I'm here. I'm at 3p. Okay, and then look, I'm at aluminum right here. So I'm only going to count this one box. So 3p1. And if I want to double check myself, I can just add up all of my electrons, make sure it adds up to 13. So I have 2, 4, 10, 12, 13. Okay. Let's do one more like that. Let's do, I don't want to get going like too crazy. Let's do I. We'll do iodine and then we'll do, oh no, let's do silver first because it comes first. And bromine. So we'll do silver and bromine. So let's look at bromine first. And let me erase some of this down here so it's just not as messed up. Bromine is on my 4th energy level, so let me kind of move that out of the way. Okay. So bromine is over here. It's on the 4th row, and it's like almost all the way to the end over here. So here's my bromine. Okay, bromine's atomic number is 35. Okay, and like I said, we're not going to do the arrows. We're going to just skip straight over to the electron configuration. So again, I'm always going to start here, 1s. How many boxes are on that 1s? It has 2. Then I'm going to the next row, 2s. How many boxes? 2. Then I keep going, 2p. How many boxes? 6. Then I keep going, 3s. How many boxes? 2. 3p. How many boxes? 6. Okay, keep going. 4s. How many boxes? 2. And then look here. Now, as I go across, I'm running into this 3D, okay, whereas I didn't run into that before. So I'm not going to skip it, because what's really happening, even though it goes back down to 3, I'm not going to reorder it out in front of this 4, okay, because what's really happening is that even though it waits to fill up this 3D is like a little bit lower down the, it takes a little bit less energy to hold electrons in this level right here. So if you kind of remember that stepwise little picture from the notes, the previous video from the POGL, as I was going through those slides, your energy levels are ordered based on the amount of energy it takes to hold those electrons there, because remember, you're pulling those electrons away from those positive protons. So those electrons in that 3D, it actually takes less energy to hold them there, and that's because this 4s is like a huge circle. It's like a huge area, so it actually covers more space and is wider than like my 3D, which is like right in here. So you can see how the 4s actually moves the electrons further away from like where my nucleus would be in the center. So don't worry too much about why it goes backwards. That's a little explanation, but if that was confusing, don't worry too much about that. Just make sure you know you're not going to skip it. So I said 4s2. I'm going to keep going. Now it's 3D. And if you don't remember how many electrons D can hold, I'm just going to count my boxes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 3D 10. Then I'm at 4P. So make sure you don't forget to go back to 4. You're always just going to write whatever is there. 1, 2, 3, 4, 5. So I only go 5 boxes until I get to bromine. And if I add all these up, then I should get my 35. Okay, so that was very tedious, all right? That was a lot of writing. So what I want to do now is kind of go ahead and show you this noble gas configuration with bromine, and then we'll do silver all together as the last one. Okay, so noble gases, if you don't remember, are the atoms in this last column right here. Okay, and they're special because they have a full outer shell, and they're not reactive. They don't react with anything. A lot of times they're called inert, and they're all gases. Okay, there's no solids or liquids in this column right here. They're all gases. So because these are kind of like the special column, that's why we call it a noble gas configuration, because everybody knows where the noble gas column is, and it's kind of an easy place to start as a shortcut. So if I want to do a noble gas configuration for bromine, okay, here's my bromine, remember. What I'm going to do is I'm going to go up a row, and I'm going to go all the way over to whatever this noble gas is right here. And if I look at my periodic table, I can see that it's argon. Okay, so what I'm going to do is come up here, and I'm going to write argon in brackets. What that's telling me as an observer, if I want to know what the configuration, what element you're talking about based on this configuration, I know, I'm just going to start at argon. So as I'm writing, okay, I'm basically all of this, let's see, I'll just put a little bracket and then I'll take it away so it doesn't confuse you, but basically this all the way to this is now all inside this argon bracket. Okay, so I've saved myself all this writing. So now when I go back, instead of starting all the way at the top, I'm just going to start on the next row after the argon. So I'm going to start at 4s2, 3d10, 5, 5. 4, because that's what it says on the page, 4p5. Okay, so then I'm going to continue writing the last bit. It saved me a whole lot of work, and it would really save you a lot of writing when you get further down to the bottom. Okay, so let's do silver. If you want to pause and try it yourself, that would be a great idea. I'm going to erase all my writing in here. Okay, we're going to do both. We're going to do the electron the standard configuration first, and then we'll do the noble gas configuration. Okay, so silver, let me tell you where it is. Right here. Let me kind of color it in. Okay, and its atomic number is 47, so there's 47 electrons. Whew, this is going to be a lot of writing. So I'm going to start at the top. Let me erase this arrow so you're not confused. I'm going to start at the top. 1s2, go down. 2s2, keep going across. 2p6, because there's 6 boxes. Go down to the next row. 3s, 2 boxes. 3p, 6 boxes. Go to the next row. 4s, 2, keep going across. 3d, this time I'm going all the way across. 3d, 10 to 4p, going all the way across. 6, down to the next row. 5s2, keep going across. 4d, but this time I'm going to run into my element, so I need to count. 1, 2, 3, 4, 5, 6, 7, 8, 9. 4d, 9. Okay, and I'm going to stop there. So now if I want to do my noble gas configuration, remember I'm going to go up a row, and I'm going to go all the way over till I find this noble gas right here. So what noble gas is that? That is krypton. So I'm going to put Kr in my brackets for krypton, and then I can just start on this next row. So all I'm going to write is 5s2 and then 4d9. So that's all I'm going to do in this video. I will upload, it'll probably be later today. I'll upload a key to all of this, so if you want to go back and check like your orbital notations or your noble gas configurations for all of these, you can. But hopefully this at least gave you enough practice so that you could start working on the homework module for the day. Don't forget to upload your documents to the assignment tab. And let me know if you have any